This lesson we're going to talk about reasoning in algebra. And what we want to do is we're going to identify and use properties to justify steps in solving different problems. So let's talk about each individual property. First, we're going to talk about the addition property. The addition property is when you add something to both sides of an equation. So if we had x minus 3 equals 7, and we added 3 to both sides, okay, that process of adding to both sides is the addition property. The subtraction property is just the opposite of addition. And in this case, if we had x plus 3 equals 7 and we subtracted 3 from both sides, that art of subtracting from both sides is the subtraction property. Next, we have the multiplication property. That's if you want to multiply both sides by, in this case, we're going to multiply both sides by 2. So that process of multiplying both sides of the equation, that's called the multiplication property. Next, we have the division property. If we had, let's say, 5x equals 10, and we're going to solve that, we would divide both sides by 5. So that art of dividing both sides by a number or any other type of situation, that's called the division property. Next thing we have is the distributive property. Anytime you have number variable outside of parentheses, for instance, if we had 2 times the quantity x minus 1 and we multiplied the 2 into the parentheses, that is the distributive property at work. So that gives us 2x minus 2. Next we have the substitution property. Is anytime you can plug in a number for a variable or vice versa. So let's say I said x was 2 and we had 2x equals 4. I could take that 2 and I could plug it in for that x. I can replace it. So any time you plug something in or replace, that is the substitution property. Next we have the reflexive property. The reflexive property is any time something is congruent or equal to itself. For instance, if we had angle A congruent to itself, angle A, that's the reflexive property. The symmetric property is any time you kind of flip-flop the order of any particular statement. So let's say we had angle A is congruent to angle B, then we can say angle B is congruent to angle A. We can just flip-flop the order. And the last property is the transitive property. Transitive property states if 2 things are equal to the same thing, then they're going to be equal to each other. So let's say we have angle A is congruent to angle B, and angle B is congruent to angle C. All right. Now angle A and angle C are both congruent to the same angle B, so that means that angle A is congruent to angle C as well. That's the transitive property. Okay, now we're going to do a few examples here. First thing we're going to do is just identify properties. So numbers 1 through 5 on our sheet here have some properties at work. We're going to just decide what properties are taking place. So on this one we have angle Z congruent to angle Z. That's something congruent to itself. That would be the reflexive property. Okay, next we have 2 times the quantity 3x plus 5 equals 6x plus 10. That looks like that was distributed there, if I do the math correct. So that will be the distributive property. Number 3, we have KL is equal to MN, then MN is equal to KL. So the order flipped. That's the symmetric property. And over here, number 4, we have angle 1 congruent to angle 2, angle 2 congruent to angle 3, so therefore, angle 1 is congruent to 3. That is the transitive property. And last, we have if 2x plus y equals 5 and x equals y, then 2x plus x equals 5. So what happened was this y was replaced with that x because x equals y. That is the substitution property. Okay, now we're going to use the property. So now this number 6 says use the addition property to complete this statement. We have 2x minus 5 equals 10, so then 2x equals what? So if I were to solve this, I would add 5 to both sides. That's the addition property, adding to both sides. So that leaves me with 2x equals, that looks like it's going to be 15. 10 plus 5 is 15. Number 7, the symmetric property of congruence. If angle H is congruent to angle K, and symmetric means we flip-flop the order, that means angle K would be congruent to angle H. Pretty simple stuff. Okay, now we're going to kind of put it all together here. We have a diagram and the problem is already set up and done for us. We're just going to justify each step. So there are 1, 2, 3, 4, 5 steps here. So I want to provide 5 reasons. I want to provide 5 reasons why these steps were stated. So in the first step here says AB plus BC equals AC. That would be the segment addition postulate, which tells us that we can add up pieces of a segment to equal the whole thing. And next thing I notice is that the AB and the BC and the AC are all gone and they're replaced with the variable expressions. That's simply the substitution property. Next thing I notice is that the 2y and the 3y were combined to give me 5y, so that's just simply combining like terms. That's not necessarily a property, it's just a step. Next thing I see from step 3 to 4 is that minus 9 has disappeared and 21 has become 30. So it looks like they added 9 to both sides, so that would be the addition property. And finally, the last step here would be to divide both sides by 5, so that would be the division property. That concludes the lesson on properties and setting up the introduction to two-column proofs for geometry by using some algebra and some properties. Hope you enjoyed it. Thank you for joining.